Hello children, welcome back to your channel Physics by Imagination. The children, in the part 1 we discussed about that is metals and non-metals. Okay, there we had discussed about what are metals, non-metals, their physical properties and reactivity of the different elements. Okay, what is covalent and how formation of covalent compounds will take place, what is dot structure, etc. we discussed in the part 1 video. Let us understand in part 2 video without wasting time the following topics: metals and non-metals. The children, metals and non-metals. So very important point, metals are odd in nature, they can give the pair of electrons, whereas non-metals are going to take the pair of electrons. This is the major difference between metals and non-metals. So I am going to take an example, that is sodium chloride. The children, it is an ionic compound, or you can call ionic bond. So what is covalent bond? Just the bond formed by the sharing of electrons is called covalent bond, like water, okay, like N2, O2, H2. Now the bond formed by sharing of electrons. So you know that sodium is a metal, chlorine is a non-metal. Now this sodium is going to give the pair of electrons, then chlorine atom is going to take the pair of electrons. I mean, it is ready to take the charged particles. When it is ready to take the charged particles, then what happens here? We know that the sodium atomic number is 11, 2, 8. So we can write that 2, 8, 1. So now here it is going to give 1 electron, and we have atomic number of chlorine is 17. So now here formation of NaCl means that is nothing but reaction between metals and non-metals. Then what happens, children? Na plus, in chlorine we have 1, 2, 3, 4, 5, 6, 7, and here empty is there. It is going to give electron. It actually, this is 2, 8, 7. The atomic number of chlorine is 17. Now afterwards what is going to happen? When it is going to give Na plus, then what happens here? The Cl, it has how many electrons? 7 in outermost shell. 1, 2, 3, 4, 5, 6, 7. And now it is going to take electrons which is given by the sodium atom. Then it is going to have to displace. Then it becomes a Cl, 1, 2, 3, 4, 5, 6, 7, and this is now the formation of NaCl. Formation of NaCl. Okay, so by using these two processes, we will get the product, that is NaCl. Or we can give rise to Na plus, that is Cl minus, in simple way 3, 6, 7, and it forms Na plus Cl. So 3, 6, 7, 8, this is dot. So this is the formation of NaCl. Means the metals are going to give the electrons and non-metals are going to take the electrons. Very important point. After that we will discuss about ionic compounds. Very important. The children, what are ionic compounds? The compounds which are very hard in nature and brittle in nature, and such compounds are called metal, that is ionic compounds, like sodium chloride, salt, and zinc chloride, hydrochloric acid. That is, we can find there is a formation of both electropositive and electronegative ions. So let us understand now, ionic compounds means they are very hard in nature. Okay, they may shine bit. So now properties of ionic components. Properties of ionic components. Ionic compounds, or you can call components, ionic compounds. So first one, very easy. That is, as I told you, they are hard and brittle. Brittle means we can break it very easily with applying force. Second one, MP and BP are very high. you know, that is melting point and boiling point are very high. So because there is a strong inter-ionic distance or inter-ionic force between the atoms, example NaCl, there is a strong electrostatic force between or electroionic force between sodium and chlorine atoms. So that which has melting point and more boiling point. So first one is odd and brittle, second one is more melting point and boiling point, means which melts at high temperature, boils at low temperature. Melting point means, you know, that the substance which convert solid into liquid, liquid into gas means boiling point. Third point, so they conduct electricity, they conduct electricity because it is conduct electricity in the solutions and in the molten state, but not in the normal state. Now see, if I take salt, in the solid state it doesn't conduct electric current, in the aqueous solution it will conduct electric current, and this is insoluble in kerosene and petrol. So first one is odd and brittle, melting point, boiling point are high. Third one is conduct electricity, and that is fourth one is soluble in water. Soluble in water, already I told you, insoluble in kerosene and petrol. These are the properties of ionic compounds, they may ask you. Okay, definitely please concentrate on this. After this we'll understand that is lower reactivity series. The children, we have discussed that is Kanaka Megaol, Jilcha. Their lower reactivity series means they are bottom one, and these are available in free in state. Okay, let me take an example, that is third point. So if I take that is cinnabar, children, cinnabar, it is the ore of mercury. Okay, so it has formula that is hydrogen, that is mercury sulfide. When I take 2 times of mercury sulfide and going to react with 3 times of what, oxygen, under heat process, this is called roasting process. Okay, so this is sulfides. Okay, then it is going to form, children, that is 2 times of mercuric oxide plus 2 times of sulfur dioxide. This is the reaction we can see in the case of lower reactivity series, and this process is called roasting. The process of removing the sulfides into oxides in the presence of air, that is called roasting. Okay, this is all about cinnabar. Now again I want to remove this oxide content. Again if I heat it, children, I am going to get, that is pure plus oxygen. So this is the process. We can see the reactions in the lower reactivity series which are available in free states in the nature. So next, after that, we are going to understand about middle reactivity series. Very important. Middle reactivity series. So like if I take zinc, okay, if I take hydrogen, if I take copper, they are middle reactivity series, like middle. So now that is, we can take middle reactivity series. That is, if I take zinc, that is very important for exam, roasting. So what is roasting? When I take, and remember, these middle reactivity series elements are not easily available in free state. They are available in the form of sulfides, in the form of carbonates. Okay, so in that form we are going to get it. Means zinc, if I want to get, it is getting in the form of sulfides. I can't get in pure form. Okay, we have to be extracted. And here very important point, and here we have in the previous process, in the lower reactivity series, we have obtained pure mercury. Okay, so that process is called metallurgy. Very important. What is metallurgy? The process of extraction of pure metal from ore. Ore means impure state. That is called what, children? Metallurgy. The process of extraction of pure elements from impure ore, that is called metallurgy, remember. Now when I take zinc sulfide and roasting, it is especially used for sulfides and reacted with oxygen, which gives rise to, that is zinc monoxide plus sulfur dioxide. Now here sulfide has changed into oxides. Now again I want to remove it. Again when I take zinc monoxide and treat it with carbon under heat process, which gives rise to, that is pure zinc plus liberation of carbon monoxide. So this is all about roasting. So in the exam definitely they'll ask you between roasting and calcination. So calcination I will tell you later on. Roasting means the process of getting the pure metals in the presence of air, that is removing sulfides into oxides, oxide into pure metals. This is called roasting, and this method it is especially for sulfides. Next, let us go for calcination. So what is calcination? See children, calcination very important. Here also we are going to obtain the pure metals, means in the term of metallurgy. So if I take zinc carbonate under heat, I am going to take, so zinc carbonate means I am going to heat the substance in the absence of oxygen. The process of getting the pure metals in the absence of oxygen under the heat process, that is called what children? That is called calcination. So it will form ZNO plus carbon dioxide. This is about calcination. This is about calcination, means the process of obtaining the process of getting the pure metals in the absence of oxygen, that is called calcination, and it is especially for carbonates like sodium carbonate, sodium hydrogen carbonate. There we are going to use calcination process. For sulfides we are going to use rusting process, that is roasting process. After this, let us understand about very important reaction, that is thermit reaction. Children, thermit reaction means it is very widely applicative of between the railway tracks. We are going to insert a liquid, that is called thermit reaction. So when I take, that is ferric trioxide and with the reaction of aluminium, so this is an exothermic reaction. In this reaction, that is under thermit reaction, it is going to produce a very large amount of energy. When there is a reaction between ferric trioxide and aluminium, it forms pure iron with the liberation of, that is aluminium trioxide plus large amount of heat. This is called thermit reaction, very important. Where it is going to react, that is ferric trioxide with aluminium forms pure iron with the liberation of aluminium trioxide. So this is used in the between the railway tracks to join the railway tracks. They are going to be used. So here it is going to produce very high amount of temperature. So the children, it is all about metals and non-metals. Okay, so today we understood metals, non-metals, formation of sodium chloride, ionic compounds, their properties, low reactivity series, about Cinnabar, middle reactivity series, roasting and calcination, and higher reactivity series. That is, we left with one point, that is called electrolytic process. So what is this process, children? Electrolytic refining means the elements like copper, aluminium, zincs are going to be extracted in electrolytic refining. So let us understand without wasting time. So here we are going to use electrolysis process. Electrolysis process. So what is electrolysis process? When you apply the current, let us consider a vessel, and I am going to immerse electrodes. I am going to immerse electrodes. So I can take as, that is, so I will release this one, children, electrolysis process. I'll write here electrolysis process, electrolysis, and here I'm going to connect to plug key through battery. Okay, this I connect it to this, and this is anode, this is cathode, this is plus, this is minus. Now I'm going to fill with this, that is acidified copper sulfate solution, that is acidified. This is the process is called electrolytic refining, means like zinc, aluminium, copper, mercury elements we are going to get in pure state. Means I'm repeating once again, that is the process of getting pure elements and removing gong. Children, gong means what? Waste materials like soil, dust and all, gong. The process of obtaining pure elements by passing electric current, okay, that is under the electrolysis process, that is called electrolytic refining, or you can call electrolytic refining. Now what is electrolysis? Dear children, when we pass the electric current in the solution of this copper sulfate, there is a dissociation of ions. The positive ions move towards cathode and negative ions move towards anode. This is called electrolysis, means the process of supplying the electric current in the solution. There is the dissociation of ions, that is positive ions move towards the cathode and negative ions move towards the anode. That is called electrolysis. Now here, if I take copper, children, that is Cu2 plus will come towards, that is cathode side, and this is we are going to take pure metals. At the anode we are going to take, that is impure, hard, thick, crude metal. So they will ask you, children, where we are going to get pure metals? At the cathode side. Where we are going to get impure metal? At the anode side. And impurities like gong particles will be settled down at the bottom of this electrolytic refining vessel. This is gong, impurities. So this is all about electrolytic refining, and thermit reaction already we discussed. Okay, then we have completely completed, that is metals and non-metals. Okay children, next class we'll understand about periodic classification of elements. Okay, I hope you are understanding this points. If you understood, please like it and share it. Thank you.